So we're looking at the second year Stats and Mechanics textbook, and we're on chapter 6, which is projectiles, and we're looking at exercise 6D, which is projectile motion formulae. So we're on question 8. I think this is the last question in this exercise. It's an exam question, so we can see how many marks each part's worth. It's also problem solving, so you might have to think quite carefully about how to tackle it. Okay, so I think this one's slightly different to the rest of the exercise, in that they haven't given us an angle and an initial speed. They've given us a velocity as a vector. But I think actually this might make it a slightly easier question, but we'll find out. Okay, so we're looking at 8a. Okay, so object is projected from the ground, so from a fixed point A on the ground, with a velocity ki plus 2j. So I is to the right, so positive I is to the right and positive j is upwards. And basically it's travelling, well, initially it's travelling upwards with twice the velocity it's travelling to the right. Yeah, so we're not given the actual velocity, but if that's k and that's 2k. So let's try and draw it roughly to scale. So if it's going k to the right and 2k up, so it's starting, label those on, so it's starting at quite a steep angle, and then it's going to slow down in the vertical direction due to gravity, and then eventually come back down and hit the ground. Okay, and so the object moves freely under gravity until it strikes a point on the ground. So it started at A and it's striking the ground at B, where obviously it's going to come to rest because it's smacked into the ground. And relative to the origin, the position vector is xi plus yj. So basically what they're saying there is at any point on the path, it's travelled x in the I direction, so x horizontally and y vertically. Okay. Right, so show that y equals, and then we've got y as a function of x. So x and y are its position vectors, so that's what I'm looking at. So if I go, horizontally is always easier because we don't have acceleration in the horizontal direction. So let's start thinking, let's change that back to black. Okay, so let's start thinking horizontally. Okay, so horizontally, the velocity is k. Yeah, I've just given that in the question. So the velocity is k. The distance or the displacement horizontally, they've told us, sorry, you can't see my screen. Right. So horizontally, the velocity is k from that vector. Displacement horizontally, they're telling me to call x. And always with these questions, hopefully if you've done the rest of the exercise, you're used to this now. We're really looking at t, because t is what connects. So whenever it's at this position, obviously t, you don't have a different vertical and horizontal time, whatever the time is, whether it's 5 seconds, 10 seconds, whatever it is, it's the same for horizontal and vertical motion. You can use suvat with a is 0, but it's a lot quicker if we just say that displacement is velocity times time. So we're calling the displacement x, the velocity is k, and time is t. Okay, so we will come back to that, and then let's go vertically. So vertically we are going to have to use suvat because there is acceleration. So I was going to the right then, I'm going to take up as positive when I'm going vertically. So the initial velocity vertically, yeah, again, they told me in the question, is 2k. The vertical displacement, they're telling me to call y. I'm taking up as positive, so the vertical acceleration is minus g, because obviously g is working downwards. And as we said before, t is just, we're just going to call that t. So I'm going to use s equals ut plus a half at squared. So s we're calling y, u is 2k, t is just t. a half a, well, a is minus g, so that's going to be minus a half g t squared. And then if I say, so sort of this is, if you've worked through the previous questions, this is a really similar structure we should be quite used to by now. Then I go back to this. So obviously this is the simpler equation, and I'm aiming for y in terms of x. So I don't want to rearrange this one. I want to make t the subject of this one. Okay, and then substitute in there. So wherever that one says, wherever this one says t, I'm going to substitute in x over k. So y is 2k and then x over k, and then minus a half g, and then again I'm substituting x over k in for t, and that's squared. And I think I'm pretty hopeful we're going to get what they've got there. So this is the result I'm aiming for. I think we're okay. That k and that k can cancel. So I do get 2x, which I wanted. When I square out these brackets, I am going to get x squared in the numerator, and the 2, up a little bit, sorry, the 2 from the half can just go into the denominator, and then the k is getting squared as well. So quick double check, not lost any negatives or anything. Nope, we're good. So just to show I've done it, we'll put as required. Okay, so not bad actually. So it looked a bit unusual to start with, but I think that was probably a little bit nicer than some of the earlier questions in this exercise.